Hackers on Planet Earth is back on the airwaves. We've had a tremendous response to the conference this year. Thank you for tuning in, for spending time with us, for being part of it all. This next talk is very exciting. It's sort of a intersection of law, history of computing, and looking out towards the future of law. And it's called On Computational Law, Why the History of Computing Could Be the Future of Law. It's going to tell some of the story of what's happened in Singapore and extrapolate what that could mean for the future there and elsewhere. I'd like to welcome Meng, Weng, Wong, who is Principal Investigator of the Research Program for Computational Law at Singapore Management University. He's a co-founder of legalese.com, and you might remember this name as a previous co-founder of pobox.com, as well as author of RFC 4408, which is the ever famous SPF anti-spam standard that we all rely on so much, even if we don't always understand it. So let's go ahead and hear what the talk has to say, and we will be monitoring the live chat, and we'll return for some questions and answers.
Hello, Hope 2020. It's 10 o'clock. Let's begin. My name is Meng. You can say hi to me on Twitter as Meng Wong. I work at a research program at Singapore Management University, which recently received a pretty chunky grant to write open source software. Little known fact, Singapore is the only country in the world run by a mathematician and computer scientist, so it kind of makes sense that this could happen here. When I say computational law, people hear robot lawyers. And there are a lot of sensational headlines out there. It's the usual AI is coming for your jobs kind of thing. And this month, there is a lot of hype about things like GPT-3. Somebody just did plain English in, legalese out, and people are like, hey, we're not going to need lawyers anymore. We have AI. I don't know if I agree with that, but if you talk to an actual lawyer, they will say, oh, robo-lawyers? That's ridiculous. You can't substitute for human judgment. Every client is different. Every situation is different. Every case is different. You can't replace me with software. So, okay, fine. I'm convinced. I'll go to a human lawyer. But tell me, why should I go to you? Ah, easy. That's an easy question. Easy. Experience. I've done 1,000 cases just like yours. But seriously, some of my best friends are lawyers. My life partner is a lawyer. If I seem critical of the legal profession, please believe me, things are no better in the world of software. So this talk is going to look at how software and law both suck in surprisingly similar ways and what we can learn from that. What, you don't think software sucks? Are you even at the right conference? Go check out this talk by Gary Bernhardt. And oh, by the way, I'm going to share all these links in a README on GitHub, and I will put that link on Twitter so you can find it. So, what happens when lawyers screw up? There are lawsuits and millions of dollars in penalties, and maybe people go to jail who shouldn't, and people don't go to jail who should. What happens when programmers screw up? Spacecraft fall out of the sky. Patients receiving radiation therapy die of overdoses. The power grid goes down because of a race condition. The list goes on. So it's really not like we have the moral high ground here. But in everybody's defense, this stuff is really hard, right? It's hard to write code that doesn't have bugs. It's hard to do a draft. It's hard to write code that doesn't have bugs. It's hard to draft a law that everybody's happy with. It's hard to write a watertight contract. You know, coding is hard, whether you're doing it in Rust or JavaScript or legalese. Let me show you some code written in legalese, right? Regulations around OTC derivatives. Actually, no, this is too easy. I'll come back to that. Let's look at this one, Missouri. You can't read this. I can't read this. Nobody can read this. This one sentence has more than 1,000 words. As a programmer, I look at this and I think, this is object code. This must be the output of a compiler toolchain. Someone wrote some high-level source code and then pushed it through, I don't know, GPT-3 or something, and this is the result. I pity the judge who has to make sense of this. or the end user has to try to understand it. No wonder there's a whole legal priesthood whose job is to interpret this for the rest of us at $600 an hour, which makes me think as a programmer, there's got to be a better way. So in 2014, I set out on a mission to do something about this. I'm a programmer. I like to think I'm smart. There are programmers in the audience, right? You're smart. And what do we do as programmers? Our job? We write detailed specifications for complex systems that try to anticipate a wide range of future scenarios. That's what programming is basically about, right? That's our job description. Well, it turns out lawyers have the same job description. They write detailed specifications for complex systems that try to anticipate a wide range of future scenarios. We do it in JavaScript and Python and Rust and Go. They do it in English. And I gotta tell you, they have it figured out. 2 years of law school and they get to program in English and they charge $600 an hour to write pseudocode. Man, I should have gone to law school. It kind of reminds me of a time when teams of developers used to write assembly for proprietary projects. This is what computing used to look like in the 1970s, before the PC, before Linux, before the internet. There was no GitHub, so of course every project would be written from the ground up, and if your project wasn't big enough to keep a team of programmers busy for several months, they wouldn't even want you as a customer. Which is basically what big law looks like today. So, my plan is real simple. If I don't get paid $600 an hour, nobody gets paid $600 an hour. Let me take you back to 2014, right? A lifetime ago, right? So HopeX was happening in New York City, and Andreessen Horowitz, A16Z, they were still trying to convince people that software is eating the world. And me, I had just come out of a huge lawsuit over millions of dollars worth of assets, and I have to say, what an education that was. Lawyers do 2 years in law school. I did 2 years on a lawsuit, and I was like, wow, I just spent 2 years time traveling to the 19th century. Why hasn't software eaten law? And then of all people, Mark Andreessen showed up and was like, bingo. So I was like, project? Shouldn't take long, right? I'm going to sign up for a hackathon, really knock this thing out over a weekend, you know? Bit of JavaScript, bit of Python, launch on Heroku. Easy, we'll be done by Monday. So it turns out it's harder than I thought. Okay, it's going to take a little longer than I thought. I got some white hair at the temples. I put on a few pounds. But I'm making progress. I really am. I got a little show and tell for you. In the next 30 minutes, I'm going to give you a tour of everything I've learned over the last 6 years. And I will show you a demo of what my team and I are working on at the research program. And just so you know, some of what I'm about to show you is real. You can clone it from GitHub. And some of it is more of a concept sketch, which our research team will turn into reality over the next few months and years. But the big idea is this, right? And this comes from a paper by Michael Genezareth, who is a professor at Stanford, and he's been thinking about computational law a lot longer than I have. If you need to solve a problem involving numbers, you might reach for a spreadsheet. But if you need to solve a problem involving laws or contracts, what do you use? There is no equivalent to the spreadsheet for qualitative reasoning. Accountants use spreadsheets, photographers use Photoshop, architects use AutoCAD, and what do lawyers use? Pretty much Microsoft Word, which to me feels about the level of a hex editor, right? No wonder this lawyer said, I'll let you read that. So earlier, I showed you this piece of legislation. Nothing special. There are millions of pages of laws and regulations that look just like this. Lawyers spend hundreds, if not thousands, of hours in Microsoft drafting this kind of thing all the time. But this is different, right? If you zoom out, you see this is a compilation target from a higher level language. Let's call it legalese, the language of law. It's a domain-specific language that lets you write law as code and then turn it back into English. If you don't like what you see, don't try to edit the PDF. Don't even edit the Word doc. Edit the source code and recompile. Let the computer export to Word and PDF so you don't have to. And guess what? The source code is code. It lives in GitHub, and every jurisdiction is just an import away. And the cool thing about doing this as code is that the compiler begins to do the job that used to be done by the human lawyer. The error messages will tell you if you've made a mistake. And in the future, you could have even more sophisticated warnings. This contract would force you to do 2 incompatible things at the same time. Or the formal verification engine knows that some situations will never arise, so there's no point talking about it. And here you didn't deal with all the possible inputs, all the possible scenarios. And here the system knows that a clause might not stand up in court. And so with a few more compiler flags, we could tell it to produce output in multiple languages. Here it's Bahasa Indonesia, because all international contracts in Indonesia need to be written in 2 languages. If both those languages are compiled from the same source code, you don't need to hire a translator and save another 600 an hour. But you know what? Once you've got the semantics in software, linearization to natural language syntax is just one thing you can do. It's an important thing to do because judges aren't going to read the code. They want it in English or Bahasa. But end users aren't even going to read the English if they can just talk to an app with a UI. The front end is up to you, but the back end we can generate. If you want it in Joules as a business rules engine with an API, no problem. If you want it in Python instead of Java, no problem. Docassemble is an expert system that asks questions and delivers documents. We can generate the interview logic from the code so the front end can ask questions and return the answer. And speaking of signing, corporate law is all about the signing. Directors' resolutions, shareholders' resolutions, shareholder agreements, deeds, contracts, minutes, notices, and it all has to happen in sequence and in order. You know what that's called? It's called a makefile. It's a build process. It's a dependency graph. You can model all that as a DAG and just automate it. So that's another thing we can do in computational law. In fact, we can compute the dependency graph as the solution to a constraint planning problem. It's basically a logic problem, right? The classic logic problem is the knights and knaves problem. One of the languages we use is Prolog, which is perfect for solving logic problems. And what else can you do with graphs? You can visualize the future. Here is a contract represented as a finite state machine. And the cool thing about finite state machines is that they are amenable to formal verification. So let me give a real quick introduction to formal verification. Here is a tweet that this guy called Ken Adams put out a while ago. He had a question about ongoing versus transient. And I saw this and I thought, dude, you're asking linguists when you should be asking computer scientists, because we have the math to do this. And by the way, this isn't just some random person on the internet. Ken Adams is the highly acclaimed author of an authoritative text on contract drafting. So I was a bit pleased to be able to help give him the answer. So what is the answer? If you look up formal verification, you will see it mentions LTL and CTL, linear temporal logic and computation tree logic. I'm not going to go into all the detail about that. I will just show you how to use LTL, CTL. So you can think about the future. You can think about possible futures as a graph of forking paths. And today we're at the top, and tomorrow we move down one layer. And if we want to talk about every possible tomorrow, we say X, because that's the next state, X for next, and A, which is all of the next states. And so all tomorrow's parties would be AX parties. If you want to say not just tomorrow, but forever, we change the X for next into a G for, I guess, global. So GA means all states in all futures. GE means there is some future in which some predicate is true forever. Or the opposite of that, AF means some predicate will always come true at some point in every future. So I'm going to skip some of these, but the idea is that CTL and LTL give us a precise and expressive language for talking about system states over time. And this language is what gives us the tools to answer the original question, an ongoing obligation in every future. You need to keep the information confidential forever, right? So that's AG. And a transient obligation, you need to pay the purchase price at some point in every future, but you only have to pay it once. So that's AF. And there's other ways of describing this. There's a standard called Legal Ruleml that just got published in April this year. And the language that they use is there's an achievement obligation versus a maintenance obligation. So instead of transient, they have achievement. Instead of ongoing, they have maintenance. But it's the same idea. And underlying those terms in English are the mathematics, the AG, the AF. So you remember how I said lawyers program in pseudocode? Computer scientists have formal languages precisely so we don't have to use pseudocode. We know that transient and achievement mean the same thing in a formal way. And that's why Ken Adams said, they're dealing with a mess and we can help. I know it sounds arrogant because, I mean, look at all the bugs, right? But we can use the same tools to solve software bugs and legal bugs. We use what's called a SAT solver, right, to solve these things. So what's a SAT solver? Now, earlier this week at Hope, we heard about fuzzing, where you basically set up a fast mutating daemon outside your front door and challenge them to get in. And with a SAT solver, you open the door, come in, traverse the internals, and try to find bugs from the inside. So have you heard of Z3 or SMT-lib? Or have you heard of TLA Plus or Alloy? So these are all sort of model checking tools. They're written in languages so high level, they aren't even programming languages anymore. They are specification languages. Super high level, right? And I'll give you an example. You know what a transitive closure is, right? It's basically all the children and all the children's children and the children's children's children. So basically all the descendants, that's a transitive closure. All your ancestors is another transitive closure. So let's implement a transitive closure in, pick a language. Let's pick closure, just a little joke. So this is how you do a transitive closure in closure, okay? And this is how you do transitive closure in Alloy. You add a caret, and that's it. Now, what does this have to do with law? Well, we live in a world where cars can drive themselves, computers can play chess, computers can play Go. Why can't computers play contracts or laws, right? Another word for a loophole in a contract, it's a bug, and the whole point of formal methods is to find bugs before they find us. In 1994, someone discovered a flaw in one of Intel's floating point units. And by the time the flaw was discovered, Intel had already shipped a ton of processors into the field, and the recall cost Intel $500 million. And after that, they were like, okay, lads, how do we not do that again? And the answer was formal verification. And 20 years later, Amazon Web Services now uses these methods. So that's a success story, right? We do learn from our mistakes. Anyway, now that you've learned temporal logic, let's see it in action. Suppose instead of working at AWS or Intel or NASA, you're at a law firm working on a multi-million-dollar deal. There's probably a lot at stake. Formal methods could help test your code and find bugs at compile time, because handling exceptions at runtime, that's called litigation. So let's look at some research from a few years ago that applied these ideas to finding loopholes in contracts. This is some work done by Gerardo Schneider and some of his collaborators. In this case, the contract they chose was a service level agreement. It's the kind of thing that an ISP or a telco deals with. And they formalized it into the kinds of operators that we just talked about, LTL, CTL. Here they look like boxes and diamonds because real computer science professors use symbols, right? And after turning this whole contract into code line by line, they fed it to the model checker, because it's now machine readable, and they said, can you find any bugs in this? And the model checker said, yes, in fact, if this sequence of actions happens, then you lose. And that is an example of a computer playing chess with a contract. It's the sort of thing which usually a high-priced lawyer would figure out by, I don't know, standing in the shower and letting their mind wander. But we have temporal logics and we have model checkers, so we can do better. Now let me show you one last thing. It's another little benefit of formalization. It turns out there's a whole genre of lawsuits over commas, Oxford commas, you know. And seriously, in 2006, there was a lawsuit in Canada, and this latest one needed a judge to come and try to make sense of a sentence that wasn't even grammatical. I don't know how that slipped through the drafting, but it just, like, it didn't make sense. And this poor judge had to go figure it out. So that question cost a few $1,000,000 to answer. So in computer science, we have these things called parentheses, and we call them nested lists, and we can say things like this, and this is all pretty obvious stuff to any programmer, right? But it's like mind-blowing to lawyers. I mean, I really feel sorry for my friends in law sometimes, because if you look at the software world, we take this whole stack of tools and techniques for granted, and it's taken us, you know, like 50 years to build this stack. But we've come a long way since the days of Fortran and assembly and COBOL. And the lawyers, what do they use? Their most advanced technology is track changes. I mean, they're still programming in a dead language, 2,000 years old, and I don't mean COBOL, I mean Latin. But seriously, if we can fill in some of these holes on the right, there's probably a company or several companies the size of Adobe or Autodesk waiting to be built, and we are going to try to build it here. And that's part of the reason why the government here chose to fund our research. Singapore is an international center for finance and for legal services. We do international arbitration, mediation, dispute resolution. There's a whole sort of generation of lawyers here who are very proud of their work. And we can see that innovation is coming to law. And if we don't step up, Silicon Valley will be like, hey, disruptive innovation, we're going to take you out. We're going to totally delaminate the legal industry from the legal profession and turn your whole world upside down. And anyway, that's my time. Thank you very much.
There's a lot of excitement in the live Matrix chat. I think we all enjoyed hearing the approach that you took. And there's a couple different things I'd like to pursue. I think the first one, though, is what's the state and what's next in terms of, you know, is there a mailing list, a GitHub, all the regular ways that people want to, you know, possibly participate, but certainly see what's going on.
Yeah, there is a GitHub account. Now, we only got the funding earlier this year, and so since March, we've been doing recruitment. And the virus made that very challenging. So we're just getting off the ground. Now, this grant runs for 3 to 5 years, so we have some runway. And there is a GitHub account that's just been set up. We have shipped our first working code, and there's also a mailing list. And I've posted those links on the chat, so you can go take a look at that.
You know, you for programmers like me and obviously like you, this was such a joy to see the smorgasbord of languages and their different features and capabilities. And so I think I have two questions. One is, it looked like these were, you were dominantly working at the procedural languages. I wonder if you looked at some of the non-procedural languages, especially Lisp.
Yeah, you know the whole paradigms discussion, right? Like there people talk about the OOPs, the procedurals, the functionals, the logic. So the thing about law is that lawyers program in pseudocode, they program in English, and that's the most multi-paradigm language you can imagine, because anything you can imagine you can say, it's not necessarily true that anything you can say you can evaluate to a truth statement. And so we are faced with the challenge of taking these sort of creative writing outputs that come from lawyers and turning them into ultimately Boolean logic, and that's not easy, right? And so we're using a range of languages. We're using Haskell to develop the DSL. We're taking inspiration from object languages where that makes sense. Like if you're describing shareholders and a class of shares, then obviously, right, classes and objects make sense. But there are situations where you use logic. Sometimes even recursion comes up because legal language will very often say things like, the value of this thing would be the value of this other thing, assuming that this other thing were not what it actually is, right? And so you have to go do this sort of hypothetical, counterfactual, recursive evaluation. So all the ideas that we see in programming do show up in law.
One thing I'm curious about that I don't know if you mentioned is what usually we call named entities. So proper nouns, names, citations to cases, which can have some pretty weird punctuation, as well as needing to identify whether it's like I said a proper name or something. So I don't know if I apologize if I missed it, but I'm wondering how you handle that type of thing, and if you end up with lexicon or some sort of mapping.
If you're talking about like defined terms, right? Like at the start of a
Yes.
contract or at the start of legislation, there's always a section that says define terms, and then you sort of capitalize them. Like the low-hanging fruit in computational law is just to like go through the document and find any defined terms that you didn't actually define. That's the equivalent of a null pointer, right? And that's the easiest thing you can possibly do. It's like your symbol table. You've got a bunch of variables, you've got a bunch of function definitions, this is what they mean. And if you try to call a function that hasn't been defined, then we throw that error at compile time. Because you wouldn't believe the number of contracts that I've read where people use sort of undefined defined terms sort of superstitiously. Right? And you're like, okay, you can't actually do that. But you can in law. People write these things even if they don't sort of parse validation. And they sign them, and then it's the judge who has to figure it out.
You showed a lot of different examples, and some of them I think were really to make it clear how difficult and how much variety there is. But I would imagine you have an actual test suite for the code, and maybe you could tell us something about the variety in the test suite. So the idea of bringing test suites to law is really interesting, right? Because you can imagine like a red and a blue come and they say, let's write some legislation. And the red guy is like, well, the people that I care about are like a certain demographic. And then the blue guy is like, well, the people that I care about are a very different demographic, and those are my constituents. And the law itself is like hundreds and hundreds of pages long. And I don't think the politicians actually read the law, right? The lobbyists write the law. And so what they should do, what they could do is they could say, I've got 100 test cases here. One of these test cases is a sort of Vietnam vet missing a leg. And another test case is the single mom with 3 kids. Another test case is, a school teacher living on a certain salary. And they could say, you know what, as long as the proposed legislation passes all the tests, then we'll sign it. Right? We don't need to know what it says as long as it's okay. And so that's sort of the test-driven development approach brought to legislation. Kind of a crazy idea. One in the test suite, typically what you would do if you were training, you mentioned self-driving cars, for example, is you throw anomalies at them. So and I know you're early in the software development, but I'm thinking, throw a recipe, throw some poetry or Shakespeare or something, and see if it, if it pukes appropriately, I guess, is probably what you're looking for.
You can basically fuzz the legislation, right? You can do penetration testing on contracts and on laws, and you could say, here's your bug, here's a situation you never thought about. And so this is a story that comes out of Singapore, actually. So Singapore for a while had a policy of, like, if you have 2 children, that's good enough. Sort of like, we want to control the population, don't go for 3. Right? And so the government said, if you have 2 kids, we'll give you incentives. And if you have 3 kids, we'll take them away. And what happened was, this happened to a friend of mine. There was the first child, right? And they said, okay, well, we can go for another one. And so they got pregnant, and it turned out the second pregnancy was twins. And so they went straight from 1 child to 3 without ever having the opportunity to stop at 2, right? And that's the sort of thing that, like, if you had a programmer in the room, right, if you had a model checker in the room, you would have found that bug.
Mm-hmm. Right, that's not something unpredictable, obviously. Yeah. There's a detailed question in the list. Someone was wondering whether you look at loglang as one of the languages.
Yeah, there's a number of these sort of constructed languages, loglang. They're not at the top of our list right now. We are just trying to get the basic language working. And once we have sort of an abstract grammar that describes events, actions, obligations, prohibitions, various kinds of deontic and temporal and epistemic modals, those are the technical terms, you can then have whatever concrete grammar you want. And so, that's something that we'll definitely look into, but maybe in year 3 or 4 of the research program.
Mm-hmm. Another detailed question is just about license. Are you looking at a GPL or some sort of a free software license for this?
Yeah, we actually had to fight for this, but all of the software that we develop at the research program will be open source. So I don't know if it's going to be GPL. I think right now we have MIT license, but we do want to get this out there. And obviously, any language or any standard that's closed isn't going to get very much traction. And importantly, building the sort of, if we are moving laws onto a software footing, in an open society, you have to have open laws. And in our case, that means open source and open standards.
Yeah, a guy named Carl Malamud who discovered that laws are not always open, and he got his ass sued for it pretty thoroughly by the German court.
That's right.
And of course, in the US, we have the Westlaw, Nexus and Westlaw issues where they tried to copyright law, but luckily that one didn't quite stick. Yeah, so I certainly agree with that. So in the US, of course, you have the United States Code. I would imagine in Singapore there's something similar. In other words, do you start with the law books, or do you start with the legislation and that sort of thing?
Yeah, the legislation. So this is definitely, this whole idea of computational law belongs to the school of legal formalism as opposed to legal realism, and there's the idea of like the civil law system and the common law system, right? And the common law system is a little hairier and it's more unruly than the civil law system, where if you look at the German civil code, for example, you will see what reads almost exactly like an OWL ontology, where they start by defining, this is an entity, this is a thing, this is a person, this is an animal. And then it sort of goes from there. And I'm like, wow, that's really structured, right? You will not find that level of rigor in the common law system, where you've basically got like centuries worth of judges saying, that doesn't feel right to me. I'm going to go make up a reason why.
It's just an edit stream, basically. It's just an edit stream. Yeah. Fascinating. So we had I'll try to read you this question because I'm not sure I get the gist. It says, I imagine there would also be room to compare computationally generated contracts to pre-existing laws and case law to ensure the contract didn't accidentally breach existing law. So I think that, you get it, okay.
Yeah, so that's basically what we would consider a consistency check, right? Like you could imagine, even without talking about laws, just talk about contracts. Suppose you're a corporation, right? And you have, in sort of your short life, you have signed 20 different contracts with vendors or customers or employees or whatever. And you've got these 20 contracts that govern your behavior as a corporation. And now you've got the 21st, and you're wondering, is there anything in this new contract that sort of contravenes something in my existing contracts? And to answer that question, right, you have to go back and read every single one and then read the new one. And this is like a classic computational complexity, big O kind of question, right? And the way to answer that question is not to hire a lawyer and say, every time I have a new contract, go think about all the previous ones. It's to turn all of this stuff into code and then run the SAT solver on it, right? Mm-hmm. And if we can do that, we really save a lot of time and a lot of money.
Yeah, I can see that right away. Somewhat of a related question to what you were talking about with contracts. And again, I'm sure Singapore has something similar. In the US, there's sort of a cottage industry. There's a company called LegalZoom.com, for example, of basically templating a lot of common contracts. So wills and rental agreements and stuff like that. And yet it seems that there's often a need to go beyond that, and that's a big step, right? So going from $39 for a LegalZoom contract to hiring a law firm to write your custom contract is a big step even for a small business. So do you think that you might reach into that? I guess is there opportunity for the second approach?
Yeah, there is. So if you're not aware of it, there's a fantastic startup called Do Not Pay.
Do Not Pay.
Actually, Joshua Browder, he's an undergrad at Stanford. He's actually from the UK originally. And he wrote a parking ticket app that basically gets you out of parking tickets because there's all kinds of technical things that you can do, right? And so they went off, Do Not Pay Law is the name, and they went off and they picked up a bunch of funding from Andreessen Horowitz. And they are doing really, really clever things that directly satisfy what Clayton Christensen would call disruptive innovation, right? Now, you hear the term disruptive innovation all the time. People talk about it, but it actually means something. And if you go look it up in Wikipedia, you'll see that there's a Harvard professor, Clayton Christensen, who talks about this. And he says, go find the people who are overserved by the current vendors in the market. And what that means is, if you are a big corporation doing like an M&A, or you're a rich person doing a lawsuit, then a law firm will charge you $20,000 just to have coffee, and you're well served by that at the high end of the market. But for most people, you're overserved. You can't afford the fancy law firm, the white shoes, and all that coffee. And so what Do Not Pay has done, they have said, we're going to do things that the average law firm wouldn't even recognize as a legal service, but which the average man on the street would really appreciate. Like, for example, there's rules where if you buy a plane ticket and then the price goes down, you're entitled to the difference, right? Or if there's like a 3-hour delay or a 6-hour delay, you get certain entitlements. Now, most people just let it go because you're like, I don't want to have to fight with Delta, right, about this. Right. But what Josh has done, he's said, that whole system of rules, I can put that into software. And if you just sort of hook me up to your email account, I will automatically monitor what flights you're on. I will figure out when the prices drop. I will figure out when they're delayed. And I will do everything that your sort of pet lawyer ought to do. And I will get that money back for you. And so it's absolutely genius. I think he's great. Another thing he's done is he's basically said, just forward your spam to me. And if enough people send me spam, I will figure out who the spammers are, and I will automate the process of launching a class action lawsuit, and ultimately I'll recover you a few $100.
Great idea. So we can forward our spam to donotpaylaw.com, I guess.
Something like that, yeah.
Something like that, yeah. Fantastic. I wasn't aware of that. It's amazing. And I like the Clayton Christian constructive innovation concept. Sounds like a good Wikipedia lookup for later after the talk. Another question that came in is about end user licensing agreements. So we know how famously long, you get these licensing agreements from companies like Apple. And so is there opportunity there to, let's say, parse and understand or summarize, or is there also opportunity to really track the changes in these things over time and look for, let's say, problems?
Yeah, the thing about these end user license agreements is that, a whole bunch of... So a lot of what's inside these agreements actually is unenforceable. And it's there sort of out of tradition, because the lawyers who write these things are like, well, we have to do this because these things ultimately get sort of measured by the client, not by their content, but by by the number of pages they're printed on. Because if as a lawyer, if I deliver like a 2-page thing to my client, they'd be like, you didn't do any work on this. And if I deliver a 200-page thing, they'll be like, oh, that's very impressive. I'm going to pay you your fee. So these things have a tendency to grow for purely economic reasons. And so I think if we are successful, then things like EULAs and things like NDAs and employment agreements and lease agreements, those things will, they'll be sort of rewritten the way like early proprietary OSs were rewritten by free Unixes and by BSD and Linux. And if, the next time you do a contract, you go download it from GitHub or some sort of contract store where you can say, oh, look, this contract has 4 stars, that contract has 5 stars. People give feedback on these things, people give pull requests, that future, in that future, contracts will represent both sides much more fairly because people have the opportunity to go edit the template in a way that they don't today.
Yeah, this is a democratization process, leveling the playing field for those that can't afford the $20,000 lawyers and expensive coffee. One of the questions I think relates back to some of your earlier remarks. The question is it possible to reverse compile existing documents? Yeah,
that's a challenge. You'd be surprised how many ambiguities show up in legal text. And I can share a couple of links about specific cases where people have said, there's this guy called Howard Darmstadter, and he spent his entire life as a commercial corporate lawyer. And when he sort of retired, he went into teaching. And in his law class, he said, okay, students, here's a contract that I've spent the last 30 years working on. I'm very familiar with this template. I'm fairly sure that it's perfect. And so he gave it to his students, and his students tore it apart. And they found all these bugs, and he was like, oh my God, my entire career I've been using this paper that really has never gone to court. So you never even know, right? It's like, imagine as a programmer, you write a program and it never runs. How would you know if it actually has any bugs, right? And yet that's the situation with law. You write a contract and maybe it's 10 years before it ever goes in front of a judge. And so if you had, if your REPL compile loop was a 10-year cycle, you'd probably be programming in Latin too.
Yeah, and the technology changes during the time as well. So yeah, so much evolution. Well, this is fascinating. I think there's a lot of interest in the potential here. You mentioned a couple times that this is a project for Singapore, and you've also talked a little bit about U.S. law, common law versus civil law, being Germany as an example. And I was just wondering how much diversity of law there is. Could you characterize how much diversity there is in different countries and even different jurisdictions within a country?
Yeah, so we see law as a problem in applied computer science. We think it's an accident of history that law has been around for 2,000 years and software has only been around for 50. And so we like to ask ourselves the question, what would be different? What if computer science had been around for 2,000 years and we were just inventing law today? How would that be different? And so we do want to build a language and a standard and a platform that pretty much anybody could use. You don't have to be Singaporean or American. If you want to transact with somebody in a foreign country, you don't speak their language, you should be able to write a contract that both of you understand because it was compiled from the same Platonic source. And so that really is our vision. I'm an internet infrastructure guy, and I see law as basically a problem in infrastructure. And so if we're successful, I think there will be, there'll be like maybe some standard, some port number, some convention, some library. This whole thing will just turn into software.
Another RTF excursion, maybe.
That's right.
So, Yeah, fascinating. I think we've covered most of the questions that came in through the live chat, and we're getting towards the end of our time. Is there anything else you'd like to say to sum up, or you mentioned actually some really fascinating links to other projects, other activities. I think anything else you'd like to share would be welcome.
Yeah, we've got a couple of resources that people should know about. The Singapore Management University Center for Computational Law, SMUCC Law, has a GitHub repo, and we will post that. You can check out my Twitter account. I'll share some of the links subsequently. So it's twitter.com/MengWong. And there's also the startup that I've been running with my partner for the last 5 years. That's legalese.com. And there are a ton of resources and readings and sort of background. It's amazing that this idea actually goes back 50 years. It actually goes back a lot longer than that. If you look at the 17th century, Leibniz had the idea that it should be possible to calculate and reason and have some sort of mathematical notation by which one could encode and answer all of the problems of human society. And so that was Leibniz's vision. And ever since then, I think people have been trying to realize it. When he was young, he thought, this is only going to take 5 years. And then when he got old, he was like, it's a much bigger project than I thought. And that was 300 years ago.
Fascinating. Yeah, there's a lot of things to follow up on. So I think we'll be watching this project. A lot of interest, as I said. We've been talking with Meng Wong, who is principal investigator and at the research program for the organization you just mentioned, the Computational Law at Singapore Management University. Has a long history, has wrangled successfully some RFCs, and even developed a standard for anti-spam email. So, I think, and I reiterate that because I think your credentials show that there's a likelihood of success here. You know, this is a really big, hard problem. Maybe the biggest, maybe you would say this is the biggest, hardest problem you've tackled, but certainly it's non-trivial in every way.
Thank you.
So we're looking forward to what's next. And thanks again for being with us at Hackers on Planet Earth.
All right. Goodbye, everybody.